Ladies and gentlemen, good afternoon. Welcome back to the 4th ICANN-APAC TWNIC Engagement Forum. In this session, there will be 3 tracks, respectively focusing on DNS, IP, and TW-Cert CC. In the first session, we will discuss current best practices for a more secure and stable domain name system. Speakers will share recent initiatives and efforts such as the knowledge sharing and instantiating norms for DNS and naming security program, which focuses on important operational best practices or concrete instances of DNS security best practices. The moderator for this session is Ms. Yien Tang. Ms. Tang is currently a stakeholder engagement manager at ICANN. She engages with the community in the Asian Pacific region and facilitates their participation in ICANN's multi-stakeholder internet governance discussions. And now I will hand the floor to the moderator of this session. Ms. Tang, the floor is yours.
Right. Hi, everyone. I hope everyone had a good lunch, and hopefully this session is interesting enough to keep you awake still. So I'm Chyn, as shared. I'm the Stakeholder Engagement Manager from the ICANN-APAC Regional Office. I'm your moderator for today's session on sharing best practices for more secure and stable DNS. So our session today will really be 4 presentations. We will talk about some of the current best practices that are recommended, as well as some of the speakers. They will also share the current state when we talk about some of these best practices. So without further ado, we will start with our first speaker who's joining us online, Champika Wijayatunga. He's our Regional Technical Engagement Manager for APAC region in ICANN. He will talk about KINDNS. So the full name of this program is Knowledge Sharing and Instantiating Norms for DNS and Naming Security. But we always read it as KINDNS because it's really long. And basically, this program talks about DNS security best practices. I'll hand the time over to Champika to start his presentation. Champika.
Yeah, thank you, Chyn. Can you hear me well?
Yes.
All right, great. And let me try to share my slides as well. Yeah, first of all, I want to thank you all for joining this session. And so in this presentation, I will be talking about the KINDNS, the tool or the framework that Chyn just mentioned. So the whole idea here is to promote the DNS security operational best practices. And so before I really go into talking about the tool itself, we need to understand the potential target points of the DNS infrastructure or the ecosystem. Because the whole point here is using KINDNS, we want to address those issues and then to apply the best practices in protecting the DNS ecosystem. So if you see here, you can see there are several components. First of all, we have our stub resolvers that usually we run in our devices, and then we communicate with the recursive servers or the resolvers. So there are many parties who run these, like the ISPs, the mobile operators, corporates, the public DNS service providers, and so on. And these recursive servers do talk to these authoritative servers. So whenever we run our zones, we run those in our authoritative servers. And DNS is, of course, a hierarchical system. And then talking about the system itself, we have the root, the TLDs, second levels, and so on. So in all those levels, we run our authoritative servers. Now, when we run those, of course, the registries, they have their registry databases. And then registries also do interact with the registrars. And then we also have the registrants that updates these databases through some sort of an interface. So usually a web interface. Now you can see in this sort of picture, there are many threats that can occur or happen. So all those red crosses, what you see here, this is where we can also get attacked, or we can have some threats. And the whole idea here is that we have to apply some DNS best practices or security mechanisms so that we can try to actually protect those places. Now, there are several mechanisms that we do recommend, of course. And now, if you think about the DNS queries that goes from the stub resolvers to the recursive servers, they go in clear text. And so if someone captures those, they can see the queries and the metadata related to that. So if you need some protection there, you could do some encryption. There are some protocols for that, things like DOT or DOH. Now, there is also DNSSEC, which is one of the very important security mechanisms as well when you speak of DNS. Now, DNSSEC is to protect the DNS data. So the recursive servers do talk to authoritative servers, get the responses, and then provide those back to the stub resolvers or the clients. Now, the whole idea here is that we have to make sure that these responses are correct. They are coming from the correct places, and then they are not modified in the middle. So this is what we call the authenticity and the integrity of DNS data. So this is provided by DNS security extensions or DNSSEC. Then we also have to actually apply the best practices related to the when we run the registry systems, registrar systems, and so on. There are lots of good cyber security practices that we can apply. And so those things has to be followed as well. And we also have to make sure that we provide secure interfaces to the registrants so that they can secure or they can provide their credentials securely and then log into these databases and then update their DNS information. So there are several aspects we have to think about when we speak of DNS. Or having a better secure DNS ecosystem. Now, I just want to give this very quick idea to let you know that there are threats in the DNS, and then there are mitigation possibilities that how we can mitigate those as well. So by applying those best practices, we can do that. Now, then I will go and talk about this tool called KINDNS or the framework. Now, the whole idea here is that we want to apply those best practices into our DNS infrastructure, the ecosystem, so that we can protect our infrastructure. KINDNS stands for, I mean, when I spell that, I always say KINDNS. That's how we spell that. But actually, it is an acronym. So you can see the expansion here. It says knowledge sharing and instantiating norms for domain name system and naming security. It's a long sort of acronym. And then, as simply, you can just say KINDNS. So from now onwards, whenever I refer to KINDNS, this is what I'm talking about. So that's the framework that we are talking. Now, the whole idea of KINDNS, again, is to initiate and produce something very simple, right, that can help a wide variety of DNS operators. So these DNS operators can be small or large. So sometimes you could be a small operator, and maybe you could be running only a few servers and so on, but still it is very important for you to apply the best practices. Similarly, you could be a large operator or a large service provider and so on. It is also important that you should apply these best practices, and also very importantly, you can also share this with the others as well, so that others can take basically follow you, right, what you're doing and the best practices and so on. So that's the idea of KINDNS, and there are some opportunities within KINDNS that you can do this. Now, in KINDNS, there are some targeted operators we have. First of all, we have authoritative server operators. So when I say authoritative server operators, possibly you could be running some TLDs, right? So you could be just like, TWNIC, because you run .tw, right? So if you're running a certain top-level domain, then obviously you'll be running authoritative servers. Or you could also be, you may not be a TLD operator, but you could be still managing some critical zones. So if you're managing some critical zones, still you could be running these authoritative servers as well. Or it is also possible that you could be a second-level domain operator, right, where you could be running your authoritative servers as well. So we can categorize these authoritative operators, and then that can be further divided into TLDs and critical zones and second-level domains as well. Now, the other aspect or the other category that we are focusing here is about the resolve operators. Now, when we say resolve operators, again, here we can further categorize this into few areas.
Sorry, Champika, can you hear us? Because we lost you.
Be a bank, or you could be a university, right? So you could be running a resolve operator, you could be running your resolvers for your own environment. And the other category would be shared private resolve operators. This is something like service providers, ISPs, mobile operators, and so on, where they actually provide the resolver service to their clients. And the other category would be public resolve operators. So this is where you provide public DNS services. Again, here I know that TWNIC also provides some public DNS resolver services. So similar to that, there are many operators out there in the world who would provide that sort of service. Now, after this, so we are going to actually, through KINDNS, we are going to focus into all these operator categories. And the other thing is hardening the core system. So this is where I was telling you that it is equally important that we have to look into the cyber hygiene of our infrastructure, all the, apply the best practices related to that. So the other aspect of KINDNS initiative is to make sure that voluntarily provide these best practices to the community, and then so that the community can follow you. So you become kind of, goodwill ambassadors there, right? So now here, actually, I don't want to go into very details of explaining every of those best practices due to the time limitation. But the whole idea here is that if you are going to evaluate yourself as a top-level domain or critical zones, sort of in that category, if you're running some authoritative DNS servers, there are certain best practices that we always specify that these are, you should follow these or you should apply these. Say, for example, if I just take one simple example, DNSSEC sign, right? So if you are running a critical zone or if you're running a top-level domain zone, you should, sign, you should DNSSEC sign your zone, right? And similarly, there are a number of other best practices as well. You can go through these details in the KINDNS website. Later, I will show you. And similarly, again, there are a certain number of best practices that we also do apply in the second-level domains as well. And then for closed and private resolve operators, quite similar as well. There are a number of practices. If I just refer to the DNSSEC, earlier I was talking about the DNSSEC signing, but here, if you're running some resolvers, you should be basically doing DNSSEC validation. There are also things like, applying the access controls and then queue name minimization, because, all the full query doesn't need to go into root servers and so on. So there are, various practices that as a resolver operator, you can apply in your environment. Similarly, for shared private resolve operators, again, there is a certain list of best practices. So all these lists that I'm going through, these are all best practices that KINDNS framework has. And then you will be actually evaluated against this so that you will know where to fix in your environment, what to fix and where to fix, right? And similarly for public resolve operators, there are a certain number of best practices as well. So, and then to harden the core, again, these are all good best practices, applying ACLs, applying principles like BCP 38, manners. So you know that ISOC has introduced manners some years ago. So this is actually KINDNS is very similar, but manners is for routing and KINDNS is for DNS. But still, when you think of your routing infrastructure, it is equally important that you should also follow best practices like manners, right? And similarly, these are again a list of best practices where you can apply when you are thinking about your core network. Now, so that was, I hope that you have got some idea about the best practices that what we are talking about. So what you can do as an operator, first of all, you can do some self-assessment, right?
Sorry, Champika, are you still online? Because we lost you. Okay, when we get him back, we'll get him to complete the last part, but I believe he wanted to say that for KINDNS, there's two parts to it. So you can start with the self-assessment. The website, if you go onto it, you key in some of the information, you will receive a report that is tagged to the best practices that listed there. And then, of course, if there's any gaps, ICANN will always be able to support those gaps. We are always happy to discuss those collaboration opportunities. And then, of course, after that, if you're ready, you can be a participant of KINDNS. So basically, kind of endorse the program. You'll get a badge as well, and your name will be listed on the website. So we'll get Champika to complete that part if he gets back online. But I believe that was what he wanted to share.
Yeah, I'm online. I don't know whether you can hear me.
Did you hear me? No.
Yeah.
Okay. Did I end that well for you, or do you want to just take 1 more minute to complete?
Yeah, I can just do it in 1 minute. Yeah, that's fine. Because I was in the last couple of slides.
Okay. All right. Thanks, Champika.
Okay, let me share this slide.
Okay, sure.
Yeah, do you see my screen?
Yep.
Oh, hold on, I think I shared wrong one. Do you see the screen now?
Not yet. And yes, we do see it now.
Okay.
We see it.
Yeah, I was explaining about the. Yeah, I was explaining about the self-assessment. So when you use the KINDNS tool, there are a couple of things that you could do. First of all, doing a self-assessment. So this can be done as an anonymous user. So yourself, your organization, you don't have to provide all these details. You can just become anonymous and provide details, and then compare against those best practices that I was going through before. So then you will know whether you have applied those best practices in your environment. If not, you can always get a report. You can download a report, and based on that, you can apply those best practices in your environment. So that is one thing. And the other thing is you can join or you can enroll in KINDNS as a participant. So you basically join this. So once you join, of course, we will have some interaction with you, and then try to understand, what you're doing and so on. And then we will provide you the guidance. And then once you basically fix those, once you apply all those best practices, then you will be listed as a operator who actually has joined KINDNS, and then others can follow you as well. Others can take you as an example, and so you become a kind of goodwill ambassador. And if you go to the KINDNS website, so this is www.kindness.org, you will find more details. You can do these self-assessments. You can also join KINDNS as well, and you can also actually join the mailing list. And I hope that this provides some sort of an introduction about KINDNS. I think my main point is try to visit the website, and then you will learn more about it. If you have any further questions, feel free to, we can have some discussion later, or you can contact me later. Thank you very much.
Thanks, Champika. So we'll open the floor for Q&A at the end of the session. So if you have any questions, sorry, you need to hold on to it just a little bit more. And in fact, our next speaker will focus on KINDNS self-assessment. So our next speaker, Jason Ling Fan-Chieh, he's the Assistant Director of the Network Technology Group in Chunghwa Telecom. And he will be sharing on operational practices of HiNet DNS, focusing on KINDNS self-assessment. Jason, over to you.
Thank you. Hello, everyone. I'm Ling Fan-Chieh. You can call me Jason. I'm from Chunghwa Telecom's HiNet DNS team. HiNet DNS is a popular DNS resolver in Taiwan, and we not only serve Chunghwa Telecom's customer. In other words, you can consider HiNet DNS as a public DNS like Google's Quad 8 and TWNIC's Quad 101. So being open brings us vast user base and massive query amount, and consequently operational challenges. So I think having the experiences of handling such challenges is the reason why I'm invited. Anyway, it's really my pleasure and honor to join this session. And what we are going to talk about is the way we keep HiNet DNS stable and secure. And how we are going to cover the topic is by going through KINDNS self-assessment. Lucky that I'm the second speaker, because I thought it was KINDNS or something, but never mind. Okay. While going through the self-assessment, I will share some HiNet considerations and experiences. Okay. All right. And this page is my understanding of KINDNS self-assessment's content and structure. Firstly, KINDNS is elaborately designed. There are multiple questionnaires. So DNS operators can choose based on the type of DNS they have. So in HiNet DNS case, we choose public recursive resolvers. And the whole questionnaire is divided into sections, including core DNS operation practices and core assistant security practices, which is related to platform hardening. And the latter is further divided into network security and host and service security. So this is also the order that I'm going to share my stuff. So firstly, core DNS operation practice. The questions in blocks on the left are what you can see on KINDNS website. So it's directly quoted. And okay, let me see. Okay, let's take a closer look. So practice 1 mentions turning on DNSSEC validation. And about this, our primary concern would be the likelihood of growing customer inquiries. If something goes wrong in DNSSEC signing, which is done by the domain owner on the domain's authoritative name server, then the resolver supporting DNSSEC validation will reply server fail in response to DNS queries related to the domain. So when that happens, the first one to be blamed would probably be the resolver provider like us, like me. So in that case, we are afraid that being obliged to reply and being unable to resolve the root cause because we are only the resolver, not the authoritative name server necessarily. That would be really frustrating and really resource consuming. So that was that's the concern part. But that doesn't mean that we have given up turning on the DNSSEC validation. We actually completed a progressive activation test in which we made our resolver validate only the edu.tw domains so that we could avoid certain increased server fail cases and inquiries. It worked, but it has drawbacks because the partial activation was done by installing edu.tw's key into resolvers in a hardcode way. And once the key is rolled over and the installed version is not updated simultaneously, resolution will fail. So that takes a deeper or extra coordination with the domain owners, which is not really scalable, I think. So in brief, some more preparation would be better. And aside from the service provider preparing for more resources, the public getting more familiar with the protocol is preferred. As for practice 3, which is about DOH and DOT, about this, I want to share that we do provide DOH trial service since 2019. But HYNA-DNS, as one of the critical information infrastructure, abbreviated as CII, has to put the availability of traditional DNS resolution as the top priority. So a DOH service is based on TCP port 443, yet traditional DNS is running on UDP and TCP port 53. Such difference takes extra efforts and mechanisms. For example, we have to make sure the server loading is within an acceptable range, and monitoring methods and thresholds have to be added and customized. Last but not least, what kinds of attacks we might encounter and how we could mitigate must be further researched. So these are also concerns about the relatively new service. Then practice 5 is about log collection. We understand the value of DNS log, but legal compliance needs to be ensured first. That's for sure, because we don't want to attend courts, after all. So besides, to collect, to process, to store, and to retrieve massive data takes expertise and budget. To be honest, that's by far beyond the scope of our HYNA-DNS team. And lastly is about network security, which we'll talk about it later, so let's skip it for now. So next. And practice 2 is about QNAME minimization, which is helpful to privacy protection. And we have made plans to support it. And we will follow our change control SOP, activating it in batches, group by group, not once at a time, so that we can avoid accidental large-scale failure. And in response to practice 4 and 6, which is about segregation and resilience, I would like to share that we do separate our resolvers and authoritative name servers with different and dedicated servers. We even further divide resolvers and authoritative name servers into groups, respectively. For example, we have geological resolver groups like northern, central, and southern, etc., which are remote backup for each other to enhance resilience. And each of the sites adopts HA structure, so the resilience is our primary design purpose. And as for the authoritative name server, we group them based on the domains they are in charge. So, for example, HYNA.net has its server group, and PTR domains has theirs. And lastly, practice 8 is about monitoring, and I'm proudly share that HYNA-DNS has multifaceted monitoring. For example, what we classified as client view monitoring includes ping and dig fail rate and query time measurement, etc. Admin view, on the other hand, includes measurement results that only the administrators have the permission to inspect. For example, like resource utilization, like CPU, memory, disk storage, etc., and traffic analysis belongs to that kind. And the dig and ping test, as mentioned, can be considered as our application layer and network layer test. So that's one kind of classification. And lastly, by system plus human, I mean to lessen the response time, we not only have our monitoring system send alert automatically, we also ask our NOC personnel to help follow up the cases, especially and even in midnights. Okay. Then comes to the network security, as promised. And it's recommended that ACLs are implemented and the egress filtering be implemented. And in KINDNS case, we do both. We follow the principle of positive listing, and we integrate with our backbone network to realize defense in depth strategy. And within our network, we have anti-spoofing mechanism for our IPs. We also participate in our PKI to help enhance routing security. Lastly, about system security practice, to keep the security of our operation environment where my colleagues and I worked, we have dedicated devices or terminals to log in the servers, and we have protected tunnels which feature two-factor authentication and encrypted connection, etc. And we also have dedicated jump server. As for operating environment where our DNS services run, we limited the logging source to HINA DNS specific jump server. And we have servers and network appliances dedicated to HINA DNS, and we use internal repository to do version control and to accept security scans. Okay, the famous CIA triad, I would like to use that to summarize all our efforts. But again, among them, availability has the highest priority. So I'll put an end here. Thank you for listening.
Thank you, Jason. So I think it's great that we're hearing from you directly the experience of the self-assessment, and hopefully we can work together soon, to get you to be a participant. All right, we'll move on to the next section speaker, which is Nai-Wen. He's the director of the Department of Technology at TWNIC, and he will be sharing on TWDNS site deployment. Nai-Wen, over to you.
Okay, thank you. Good afternoon, everybody. This is Nai-Wen from TWNIC. Okay, today we are talking about Taiwan DNS deployment status. Okay. This is our content. I will talking about current status of authoritative DNS, case DNS, and the future work. Okay. Taiwan DNSSEC, we TW enabled DNSSEC in 2011, more than 10 years ago. And in the second year, the second level, TW also enabled DNSSEC, and EDU also enabled DNSSEC. And but until October, the registration can upload DNS from a resource portal. And the next year, 2013, the TOV.TW enabled DNSSEC. And until 2017, all registrars, the DNS hosting service support DNSSEC. So until 2017, user can easily enable DNSSEC if you use registrar's DNS hosting service. Okay. This first I was talking about authoritative DNS server. Okay. These statistics are TWNIC in charge the top level and the second level domain. There are the number of DNSSEC enabled. Total there are 1,500 domain enabled DNSSEC. It is very small. Okay. Total there are less than 1% of authoritative domain has enabled DNSSEC, and in enabled domain, enabled DNSSEC domain, they have 5% DNSSEC validation failure. Okay, you can see the pie chart. There are over 70% of DNSSEC validation failure because the DS does not update. No. There are 41% is the domain name. They have before they enable DNSSEC, but maybe they change it to another DNS service provider. The service provider do not support DNSSEC, but they must remove the DS record, but they do not do the action. And the 31% is the DS and the DS key is not the same. Okay, the key chain cannot is a key pair cannot match. So there are over 70% is the DS record issues. So because when user want to update the DS record, they must go to the registrar website to upload the DS record. But the DS record is a very long nonsense string. It is not easy to copy and paste to the registrar, the web portal. So there are new RFC 8078. There is the managing DS record from parent via CDS and the CDS key record. Okay. It is the solution to maintain the DNS key chain between the parent and the child DNS server without user to update the DS record on the registrar website. Okay. Well, we have run a check on all .tw delegate domain. There are more than 2,000 delegate domain have CDS record. So it means there are more than 2,000 domain and they already support RFC 8078. But currently we do not enable this function. If we enable this function, maybe there are another 2,000 domain that they can enable DNSSEC. But there is an issue. We run the test on we scan all of the domain in .tw. It takes more than 30 hours to scan the delegate domain, the old delegate domain. It's a long time. If you want to support RFC 8078, you must check your subdomain every day to check if they have a CDS, if they want to update the DS record. So if we want to support RFC 8078, we must have a solution to speed up the process. Okay. Now talking about KINDNS, we check our .tw DNS log. We found there are more than 90% of KINDNS server already support DNSSEC. They have the DNSSEC capability, but only 4% in Taiwan KINDNS server has enabled DNSSEC, enabled DNSSEC validation. There are two data from the APNIC. They have some statistics to measure every country their user's DNS server is support DNSSEC or not. In Taiwan, only 4%. In the global, there are more than 30% support DNSSEC. In Asia, there are more than 20%, but in Taiwan, only 4%. So there are some future work we need to do. First is ask resource DNS hosting service to enable DNSSEC by default. In Taiwan, I don't know we can do this enable the DNSSEC without users' permission or not. But I know some CCTLD, for example, like .NN or .CG, they are high percentage of DNSSEC because their resource enable DNSSEC. Their resource enable DNSSEC in their DNS hosting service by default. Second is the DATATable will support the RFC 8078, but it needs some time to set up the configuration. And the third is the encourage ISP to enable DNS validation on cache DNS server. I think our government, NCC, has some pressure push ISP to do that. Okay, any question?
Thank you, Nai-Wen, for sharing the stats. So we did start some conversations with TWNIC about enabling DNSSEC in Taiwan, but we'll definitely continue that conversation and see how I can provide some support as well if needed. And next, we'll move on to our final speaker today, who's joining us online, Edward Lewis. So Ed is our senior technologist from the Office of the Chief Technology Officer in ICANN, and he will be sharing some information on assessing RPKI deployment in TW. Ed, over to you, please.
Welcome. Thank you for your attention, and I hope things are shared appropriately. You can hear me and you see my screen?
Yes, to both.
Okay, good. Okay, so my talk here is about crossing two different areas of security work that's been going on for a number of years. It's called Assessing RPKI Deployment in the .tw. Now, dot's important because I'm talking about the DNS. Oh, excuse me, let me get to the right screen. So this is a talk that's focusing on RPKI, and it's looking at RPKI used for the DNS. The DNS is a protocol that we're talking about quite a bit today. I think most people here understand the DNS, or what it is at least. RPKI is a method for protecting routing. Maybe you're not as familiar with that if you're a DNS person, because in the DNS, routing is just it's a lower layer. It's very important, but it's not something we really concern ourselves much beyond Anycast. So what I'm going to do here is I'm going to assess RPKI in the DNS as a measurement on the routes to name servers. And one question you may want to ask yourself is securing the routing below the DNS really important? Is it more than a redundant security because of other things we do? So the DNS is a protocol. It's a target for a lot of malicious activity out there. We're probably pretty much aware of that. DNSSEC, we have that. That's a great tool for protecting the data as it flows through the DNS. But we know that that's not enough. There are other best practices, and the KINDNS covers a lot of that, and the previous speakers talked about their application of that. We protect the DNS many ways. Now, RPKI is a separate thing. It's a public key infrastructure. It's meant to secure BGP against invalid or unauthorized route announcements, and the crucial part of this is called a ROA, and I'll get to that in the next slide. The basic problem here is that if the routing system leads packets, DNS queries to the wrong place, bad things are going to happen, and the application can't fix data that's gone the wrong direction. A ROA, to give you a little deeper look into this, it looks at the routing announcement, which says here's a prefix IP range that goes this way, and it goes through ASN numbers to a last hop, and that last hop is called the origin. So you take the prefix and the origin, you put that together, and whoever's arranging for the routing, they then sign a certificate saying this is a valid route. If you see this route, you can use it. If you don't find a signature over it, you shouldn't use the route. You should filter it out, maybe. So what did I do? We took the .tw zone, took the zone file from TW and looked at the delegations just in that one file. And to see how many, using that as a starting point, how am I going to measure RPKI in use to protect the TW registrations out there? And I'll have a comparison measurement, which looks at the core, which is the root zone and other TLDs. And I'll present that too, just for a comparison's sake. Because in the past measurements and presentations I've done on this topic, I've looked only at this at the top of the DNS. This is the first time I've gone down a level into the TLD. And it's the operational patterns. What happens at the TLD level is much different than what happens at the root level. For those of you who studied DNS will be surprised, or wouldn't be surprised, but those who didn't think that much about this, it is a big difference. As we go down the level, the way the protocol behaves changes greatly. So what do? This is a text version for those who want to see the details. I take an NS record, I go take the name server, I get the address records, I get the addresses. I then go to a service called IP to ASN. It's run by Team Cymru. They do this for the good on the internet, and you give it an address and it tells you information about the routing information going towards it, what prefixes it fall into, what AS number it goes to, and I grab that, basically the route origins from that. And then I take that information, I go to a thing called Routinator. Routinator is a program that's distributed by NNet Lab that lets you look at the ROA coverage for routes. You can ask, here is a route origin. Is there a ROA for it? And they'll say yes or no. It's a strictly binary, yes or no situation. Another way to look at this for those who want to see more graphical pictures, domains, they use name servers. They share name servers. Name servers support multiple domains. Name servers have addresses. They may have multiple addresses, V4 and V6, or maybe a couple of V4s. They share, addresses can be shared too. And then below that, addresses use route origins. They may fit into one, or they may share one route origin. And a route origin itself then has the ROA as a tag to it that you see down the bottom. So in the study, of course, since I'm looking at the inside of a TLD, I see a lot of unexpected things. So there's a lot of things I throw away. There are cases where the TLD delegation goes to different name servers than would actually answer. There are some delegations that go to name servers that use non-routable IP addresses. Obviously, those domains are not going to work very well, but they're in there. And I just ignore that for the time being. I don't want to have to dive into all of the possible issues that we're going to run into. So the quick results. This is basically the big moment of the talk. Breaking down the TW zone, I have 118,000 delegations. From that, there are 16,000 name servers in use. And you can see right away that although a delegation should have multiple name servers, and you would think that if I have 118,000 delegations, I'd have 200,000 or 300,000 name servers. I don't, because a lot of delegations share name servers. It goes down pretty quickly. Those 16,000 name servers use a total of 23,000 addresses. Again, I would have expected that to be about double because we have IPv4 and v6, but not everyone's doing v6 everywhere. And there are some name servers that have multiple addresses, which skews that another way. Now, from those addresses, the 23,000 addresses, there are about 6,000 route origins for that. Again, many addresses can be in the same /24 IPv4 address routing table, so that's not unusual. And it just, first it's striking how much is shared across the ecosystem here. Now, the bottom line, the number that I was trying to come up with was, what is the coverage of routes? How many of these routes that are serving all these name servers are covered by ROAs? And you can see at the bottom, it's 3.9% coverage. That's kind of a small number. 245 had valid ROAs on the day I did this. This was the 10th of May, about 2 weeks ago. Now, I want to be clear that these are the name servers inside .tw, not below not lowering the stack either, but just TW. However, TWNIC's name servers, they are all covered by ROAs for the TLD itself. Now, so I do this work and I try to find patterns of deployment. Is there an operator that's done this in a significant way? Are there operators that are doing this together that we want to say, why do they go forward and why does it not go forward? Are there autonomous systems in TW? Are they more likely to deploy or as opposed to autonomous systems that are outside of TW, globally, basically? And is there any telltale pattern of who's deploying this? And I went through the data and found nothing. There's no significant implementer. There's no rhyme or reason to this. It just hasn't been any pattern of deployment. Even when I tried splitting it between what was in TW by country code, but inside or outside of TW, that didn't change the number. So let's look at how this compares to the only thing I've measured so far, which is the core, which I'll show briefly here. The core is the root, the TLDs, and the RAR, the Regional Internet Registry top zones. And that comes out to about 30% if I look at it all together. And this is a year's worth of observations. And if I split that piece by piece, I see that CCTLDs are roughly rising towards 50%. The reverse map zones, the RAR zones, actually they're falling, but that's a numerical trick in there because they don't have very many routes involved. If one goes off, it goes down quite a bit. And the GTLDs are rising slowly, but they're down around 15% right now. They're not very well covered. So in summary there, 3.9% in TW, 30% overall of the core, the top of the DNS, 50% of the CCTLDs together. Is it surprising or concerning this? Well, no, they're two completely different measurements, but they bring up some other issues we want to think about. Oh, a question I had earlier was, is RPKI needed if we deploy DNSSEC? I've heard that people say we don't need to do RPKI. It's not important because we have DNSSEC. Well, first of all, DNSSEC, I went to see how common DNSSEC was in .tw, and it's actually even less common. It's less than 1%. And a previous speaker, unfortunately, Nai-Wen, I hope I'm bad at the names, unfortunately, but he had about the same number, 1% coverage for that. But still, even if DNSSEC was out there, DNSSEC only gives you answers for what you receive, and you have to receive it through the routing system first. So let's think about some other things here. Are operators well enough aware of RPKI? That's generally what's been said, and also for DNSSEC, we have to promote it by speaking more about it. But it's also possible operators are aware of RPKI and DNSSEC, but they have other reasons not to go forward. And I think I've covered this in the previous slide, saying that DNSSEC works only if you get the response. So if the routing system is attacked and you don't get a response, you'd have nothing for DNSSEC to handle. And if attack, and I'll use this next slide to show this. If you have an attack where I get my data back and forth from the TLD name server, and I'm sent off to another address down where the true name server is, but the routing system redirects my queries to a false name server, DNSSEC has no chance. You're not going to get back a signed answer. You're not going to get back, you may not get back any answer if that false name server is just swallowing the queries. Even if the true name server did see the query, it would be great. He could send you back the response, but if the routing system is in the way, it may not even know that you were trying to ask the question. So it's kind of important to have the routing system secure. So let's talk about the barriers to our deployment. It's an ongoing area of research that I've been working on. I'm trying to figure out why aren't these things rolled out? And I've come down to a couple of situations. One is operators are unaware of this, but frankly, operators are a smart bunch of people. They know a lot more about what's going on in development, but their job is different than to roll out new things. Their job is to make sure things work. Now, there are operators who are concerned that the features that are being rolled out, like RPKI, will not work properly. I've heard some questions about whether or not there was sufficient trust in the way it was put together. And there's a lot of questioning of that, which is really good investigation to do. Some operators are concerned about managing the failure cases. What happens when things just don't go right with this system? What if the RPKI is missigned? What if DNSSEC is missigned? How do you handle these things going bad? What do you do? What's your fallback plan? Some operators are also concerned about the risk of changing. I mean, just introducing a new service is scary. One operator said that we have a DNS that's running right now. We have the routing system that's running right now. If I make it so that routing possibly could say this is a bad route in a wrong way, you lose your DNS too. And we don't want to lose everything because of one little mistake in what we're doing in rolling out new features. Now, and the last item is something that surprised me in one of my more recent interviews with operators. It said that some operators, they want it. They want to roll something out, but they don't have permission. Because an operator runs to an SLA, a service level agreement with usually a contract monitor, could be the government, could be their business case, their business people. And those folks may be more reluctant to roll out something that they're not sure it's going to work perfectly. They're afraid of security actually hurting themselves instead of helping themselves. So, where do we go? Right now, we really want to have a good, secure network. Good and secure are important things here. DNSSEC secures the data as it goes through DNS elements. We know that has a very low adoption rate in the data we've looked at here. Our RPKI ROAs also make routing safer, but they also suffers a lower adoption rate too. And there are other security gap fillings advancements out there that we need to address for different reasons. Now, so one of the discussions I'd like to have with folks, and if I were there in person, I'd be very curious for some of the operators out there who may have elected not to roll something out, or even if they have rolled it out, what were the stories went through. I'd like to know whether promotion of technologies in training and building, is that what we need to do? Because that's what we've been trying for a good long time. I've worked with DNSSEC deployment for 25 years, literally 25 years, since 1998. RPKI is following the same trend in my eyes too. We try to promote these through education, but maybe that's not the best way. Maybe it's not sufficient. Do we need to improve the technologies, tools, and services? I've heard that these new ways of doing work need more monitoring. They need more tools out there. They need ways to measure this stuff. They want to detect errors. How do you know that your DNSSEC or RPKI work has been accurately generated so that it's used the right way? And what do you do if you have to undo something like, for example, negative trust anchors if you had missigned DNSSEC? And the other thing is maybe we need to address the risk management side of all of this. We want to take the risk out of deploying for the first time, and we want to take the risk out of actually relying on this new security out there. And that's an area that really hasn't gotten much attention. And it might be necessary that we go back and start looking at that as operators are probably much more risk aware than protocol developers are. And finally, are incentives needed to balance the cost-benefit equation? We talk about rolling a new service out there might benefit somebody else, but you take on the cost yourself. What kind of incentives are going to be needed to do that? Because I do know that in some areas of the world, DNSSEC has gotten a lot of more deployment because there was a subsidy. There was some reason for a operator to go forward by a cheaper, a lower registration price, for example, or better services out there. For RPKI, that's a different area. We're talking about ISPs and network routing. We have to look at what's going to incentivize someone to roll out these improvements out there. And so with that, I'm at my last slide for Q&A, and I guess it doesn't hurt to be a little short on time as we get more discussion. I hope that's acceptable to the chairs.
Thanks, Ed. I was just going to say, if you could stay back just at the previous slide, because I was going to ask our fellow speakers here on the panel if any of you have any direct feedback to Ed's question, or is that something that you need more time to think about in terms of local experience? Just quickly checking. Jason, do you have any immediate input for Ed's questions for now? Did you have it? So basically, he's asking about both the DNSSEC deployment and RPKI, whether there's any promotion of technologies, training, building that's required, or any improvements, or if we need to, have any risk management or incentives locally. But it's okay if you don't have an immediate question, because these are tough questions, I know. I was going to ask Nai-Wen as well. Maybe just raising it for you guys to think about, and if you have any input, we can talk about that in a bit. But maybe I'll just open it to the floor first for Q&A, and if you guys have any input, just let me know. Okay. Right, so let's go to Q&A now. Does anyone have any question from the floor?
So for our on-site participants, if you have any questions, just feel free to come forward and use the microphone stand in the hallway. And for our online participants, if you have any questions, please type your questions in the chat box. We will help direct the questions to our panelists. Thank you.
Everyone is really quiet. So I guess our speakers did a good job in explaining the information. For Champika and Ed, do you guys have any extra comments or questions that you wanted to share?
Sure. I would say I really wish I was able to be there and have this discussion, because I know sometimes it's harder to open up about operations remotely or in a conference room. But unfortunately, I couldn't make it this time. I hope to be there at some point in the future.
Thanks, Ed. Yeah, we hope to get you here as well. Maybe next year we'll try and arrange for that. It might be easier to have that networking here and face-to-face time discussion as well on site. Champika, do you have anything to add at this point, or are we good?
Actually, I also want to echo what Ed said. I mean, I wish I could be there in person, and hopefully in a future event I could be there. So I could meet up with the operators and talk to you as well. And one more important thing, it is also very good to hear that especially HiNet, they have done some self-assessment on KINDNS, and also the number of sort of evaluation activities that they have gone through in relation to that. And if HiNet is keen, we can always work with you. And especially, you can be part of KINDNS as well. You can join KINDNS, and we are happy to work with you and help. Also, actually, it goes to other operators as well, not only Net. If anyone else is listening, same goes to everyone.
Thank you, Cham. Nai-Wen, do you have any final comment or input?
I think I have a question to Fan-Chieh. Okay. Do you? Well, I know you have support DOH on your DNS server, but I think it is not official announced, right?
True.
Yeah.
Promoted, but it's there.
Do you promote the DOH, because currently the clients like Firefox or Chrome, they already support DOH or something. The client, even Linux OS or some, they can enable DOH or DOT. Yeah.
Firstly, sorry, I haven't followed the status quo, but according to my impression, it's mostly decided by the browser or the application which supports the DOH customization or not. So our strategy is firstly to make things work and prove that it worked, and if it's popular, then we can consider devote more resources into it. But whether the application like browsers can support the customization or not, we're kind of in a passive state, which means we cannot control that part. Yeah.
Okay. Another question is, I know your DNS service open worldwide, right?
Right.
Yeah. In my experience, we have Core 101 DNS server. We open worldwide.
Okay.
But the DOT or DOH, the most users come from China.
Okay.
Yeah, it is an issue. In Taiwan, there are not so many users, but almost maybe more than 80% is come from China.
Mm-hmm.
So if you open worldwide, you may face the question. Yeah.
Thank you for the intelligence. Really important. Thank you. since I'm holding the mic, so I would like to echo that I personally agree that, especially in DNSSEC, more promotion of the technology and more training and more risk management, etc., will be helpful, I believe, because us, the resolver provider, we aren't afraid that we are facing customers' inquiries asking us why the domain is not resolved, why its server fell, and we have to explain it's not our fault. So in that case, if there's a website like a online inspection, which is in plain text, that ordinary people can understand that. So I think that would be really helpful in the situation that we reply to the customer. Okay, that's great.
Thanks for sharing that feedback. I know these questions are definitely not something that we have immediate input on. We need to think about it a little bit as well. So thanks, Ed, for raising those questions. As we move ahead with discussions with the Taiwanese community here, we'll definitely think of this as well, and we can further discuss locally in Taiwan. And I'm just going to open up the floor one last time in case anyone from the audience, if you have questions. Going twice, last time, no? All right, I think we can end the session then. Thank you again for all the speakers, especially Ed. I know it's like 3 a.m., 2 a.m. for you. Thank you very much. Champika as well. I know you need a lot more rest. So thank you again for joining us online, as well as Nai-Wen and Jason here on site. And thank you to the audience for spending time here today with us. Thank you.
Thank you, Ms. Tom. So before we close this session, I would like to ask the moderator, with all the panelists, to have a group photo together. So we would like to invite Champika and Edward to look into your camera and join us for a virtual group photo together. Okay, so everybody, we can just look to the front with your prettiest smile. Beautiful. Okay, ready, set. Okay, smile. Very good. Okay, so for the second one, everybody, we have a go-to pose in Taiwan. So everybody, let's thumb up together with your right thumb. Yes. Perfect. Okay, thank you very much.